Okay. Hi everyone. We're gonna finish day 3, part 2 of Advent of Code today. We got part 1 yesterday, so I'm not gonna read the whole thing again. But yeah, we skipped part 2 because we didn't have time. So let's do it now. Okay, so part 1 was like finding the part numbers here, where like any number next to a symbol was considered a part number, even across diagonals. Just turn down my music a bit. Okay. Yeah. So that was part 1, and part 2 is now no, only stars with exactly 2 adjacent numbers are gears, and we are trying to find the gear ratio. That means if we have like this one that's only adjacent to those 2, then the gear ratio is this number divided by this number, right? And that's really tricky in assembly. We have some of the tools, so let me just switch back. I think it's less difficult than it seems, maybe. Let me just switch my screens. Let's code. There you go. Okay. We have some of the tools, so let's just. Not true. Okay, so what we did yesterday was that we would go through and we would remember every number, right? We would remember every symbol, and we would like if there was a number where we didn't know if there was a symbol after it, we would like keep it and then reset it once we like found the number. We would add that to our part numbers and then reset this one to 0 so we don't count it twice. We don't need to do that part anymore. So what we're gonna do is we only care about stars now. We don't care about any other symbols. That makes things a little easier. And we care about stars with exactly 2 adjacent numbers. Okay, so what do we need to do? We need to keep track of numbers on the previous line. We don't care about like only counting them once. We can count them as many times as we want. Or actually, I mean, we count them once, but we like don't need to reset them or anything anymore. And we care about immediately adjacent numbers, and numbers immediately before, and numbers in the next line. Those are the hard ones. Hello. That's that. Okay, so one kind of difficulty we have is we might have something like this. Wait, let me just construct something. Is there one? No, I don't think there's a good example here. But let's say we have something like maybe 5, and then here's a gear, and here's a 4, and then here's a 6, right? Like, so how are we gonna do this one? We're gonna count this 5, then we're gonna count this 4, and then we're gonna do the star, and it's gonna interpret those 2 as its like numbers. And so we're gonna add the gear ratio here already, but then once we find the 6, we need to like invalidate this gear and remove it from our total. Right, and that's tricky. But I think that's doable. I think that's possible. We just like remember that this one had exactly those 2 numbers, and if we come across it again, then we just like calculate the gear ratio again and subtract that from our total. I think. Yeah, but might not be that easy. Okay, so I'm kind of not entirely sure if we should like try to modify our existing code or just rewrite it from scratch. I think we should rewrite it. Because like there's a lot of like messy magic around like these these like not bit masks, but byte masks. What are they called? Bit sets. You know what I mean. It's similar. Yeah, I'm doing Advent of Code in assembly. And it's really tricky. Because we're doing it in one pass, right? So we need all kinds of bookkeeping. And that's not easy. Okay, so I guess, yeah, I'm just gonna remove all of this and just rewrite that, because it's like, I think the interesting parts aren't even that complicated. We can just rewrite those. Okay, but let's think about our data first. So we have like our number buffers now here. And we're gonna keep those just like we did. Oh, actually, are we gonna keep those? Yeah, start and number. Yeah, we are gonna keep those. And we can use with Delphi. Oh, nice. That's not one you hear about very often. Okay, so we're gonna do we're gonna keep our number buffers, but we are gonna do our symbols a bit differently. But that's gonna work. So we're gonna have our like symbol buffer 1, and that's gonna be reward. That's gonna be like an array of what? Of like position, I guess. As well as what else? I guess like number 1 and number 2. And if those are 0, we haven't found one yet. Hello, Boomerang. Nice to see you. Yeah. Okay, yeah, let's do that. So those are 3 DQs. And then same for buffer 2, obviously. And previous symbol is pointer to one of those, and so current symbols. Are we gonna need a count? Are we gonna do an offset or count? That's an offset because we're using an. Actually, it's still a count for both because it's the offset. Yeah, really hurt me yesterday because I yeah, couldn't remember that I had to do times 3, no, plus 3 times 8, right? So let's do count. That's easier, maybe, hopefully. Okay. Oops, that's not previous count, that's previous symbols count. Yeah, because those are different. Okay, so that should be our data representation, hopefully. Yeah, so we're gonna have 2 buffers. Excuse me. And actually, do we need to? Yeah, we need to care about gears. Actually, we don't want symbols, we want gears now. Because we don't care about any other symbols. Let's also call them that. Yeah. Okay. Right. Yeah, okay, that's good. See that compiles, I guess. It does. Oh, that's part 1. No, it doesn't. Current symbols. Where am I still using current symbols? Oh, on symbol. Yeah, I mean, of course. Symbol buffer 1, right? Call those gear buffer 1 and 2. Okay, cool. So it's still compiles, and now let's do our loop again. Okay, so how is that gonna work? So we use our 14 as our one based index again. We'll loop through, and I guess we no, we can't just. I don't know. The difference is we don't need to care about those kinds of symbols anymore. So yeah, we should actually have just do gears and treat those just like dots, because like behave just like dots for our purposes. Yeah, okay. Right, so we're gonna loop through 14, jump back into the loop again, obviously, and yeah, read the character, compare that one with what? This 0, which is end of file, and in that case, what are we gonna do? I'm not sure yet. Let's skip that one. Actually, actually, we know exactly what to do. We're just gonna jump to the end here. So that's on the end of file. And otherwise, we'll see if it's a new line. Which, this is not a new line in Lesson. This is a number consisting of the ASCII codes of backslash and n. Like a 2-byte number. That's so horrible. Okay, so on new line we're gonna do something, not sure yet. What yet? Okay. Right, and if Rx is a star, we know we're in a symbol. No, not in a symbol, in a gear. So we're gonna jump to on gear. And otherwise, that's the case where Ix is what? Ix is less than 0. No, I guess. Let's call it on for consistency. And also, oh, not if it's equal to 0, but if it's less than 0, or if it is larger than 9. Then we're gonna ignore it. And yeah, otherwise, it's a number. Right, so yeah, it's a number, and so we're gonna subtract 0 to get the actual numeric value. Okay, so far so easy. Yeah, okay, so which case are we gonna do first? I guess unignored is just gonna jump back into the loop. I'm not sure if we need to do something here, so let's keep the case, but for now it's just gonna jump to the loop. Okay, so if we find a gear, yeah, gear's easier probably, because numbers are annoying. Numbers are really bad, because like we can have multiple gears per number. God, that's terrible. So we could have like 2 gears here, and then we need to count both of those while we are traversing 944, but we can only count them once, not twice. Oh, Jesus Christ. Okay. Yeah, let's not do numbers yet. Let's do gears first, because those are easier, I think. Okay, so right, if we hit a gear, what do we need to do? We need to later check the previous line for numbers. If we have a number immediately preceding, I'm not sure what to do. Actually, we can just have a like thingy for that, right? Yeah, let's do the case here. I think it's easier. Hello. Thanks. Yeah, it's also fun to do. Just kind of getting difficult, and I've only skimmed day 4 yet, but it seems hard. So I might not be able to do day 4 today. Might need to do it tomorrow or maybe later. I'm not sure. But yeah. Okay, so we need to check the previous line. We need to check immediately preceding numbers. And we need to keep track of this here for the next line. And keep track of here for immediately immediately for numbers immediately after. Right? Okay, so that's what we do on a gear, and then we jump tailcoil back into the loop. Okay, actually let's do the checking part first, because that's actually not that bad. So, actually let me just write that down, because it's really nice to have here. Find a gear to check if there is an immediate preceding number. Actually, there can only be one, obviously. Keep track of this gear for the next line. Keep track of this gear for the number, potential number immediately after. And what we did yesterday was that we, like inside the number code, like in that one we were like focused on the numbers, here we were focused on the gears. We would like immediately and then we would like immediately check the next character and see if that one was a gear or was a symbol. We would like immediately jump into the handler code and had like some duplication there. I don't want to do that again. I just want like a flag or something. Actually, a number, like a number field. For if we have if we had a number immediately preceding, and for numbers if we had a gear immediately preceding, right? And I'd rather do it like that. So yeah, let's do that part. So yeah, make the previous line one numbers. Let's do a loop. Okay, so what are we gonna do? We are gonna move use Ix as our index variable thingy. You know what I mean? Iterator. What's the I in a for loop called? You know that variable. And what are we gonna do with that one? Yeah, right, so at the end we're gonna increment Ix, and as long as Ix is where is it? Current. Wait, we're looking for previous numbers count, right? Previous numbers count. So if Ix is larger or equal to previous numbers count, we wanna jump to G to previous number done. Is it auto suggesting those because we have them in the other file? Yeah, it is. Okay, that's good. But I hadn't deleted some code maybe. But I have. That's fine. Okay. Right. Okay, so yeah, I'm gonna jump out of the loop. And if that's not the case, if we are staying in the loop, we are gonna actually check the thing. So yeah, let's see. Let's move our what do we have? Start and end position, right? Yeah. Let's move our start position into RBX. That's gonna be actually no, we need to move our actual previous numbers pointer into RCX because it's a pointer to a thing, right? So we move the we need to dereference one more. I think you can use like Lear for that, but I don't remember how Lear works. Wait, let me just look that up actually. Yeah. That's effective address for him. Okay, that's useful. Okay, that's not helpful at all. Solutions between moving. loads a pointer to the item you're addressing, loads the actual value. Okay, so clear is like references the thing. Yeah, no, we don't want to do that. Okay. So we actually want to move here. Leah goes in the other direction. You can like load the address of something you're referencing. That makes sense actually. Okay, so let's not do that. Let's just use RCX for previous numbers thing. And so we're gonna move RCX plus IX times 3 times 8, right? Jeez. Yeah, that's because that's our size per array element, right? Because we have 3 keywords. Yeah. Okay, so that's RBX. And then there's that's our start position. And then RCX is, oh no, we've used RCX already. Let's use, you know what, let's do this in order, just so it's not as confusing. CX is our start position, and DX is gonna be our end position, so that's plus, times 3 times 8 plus 8. This is, let us do that. I'm not sure yet. Let's try on that. No, it doesn't. Oh, it doesn't let us do either. Wait, why doesn't let us do that? Do we need to write out 24? No. Does it let us do times 8? Yes. Oh, it can only do times 8. Okay, then never mind. These are not counts, these are offsets. Okay. Huh. Didn't know that. I guess it makes sense, kind of. Let's see. Like that's probably only like a bit that says times 8 and not an actual number. But okay. So with that, then let's add ix 3 times 8, and then that's just ix. And that's plus 8. That's okay though, right? Yeah, maybe. Previous number must offset. Offset, not offset. Yeah, that works. Okay, great. Okay, right. So we have the start position, we have our end position, and actually we can just compare those. So if actually, yeah, we can do this, merge those comparisons. We don't actually need to move anything. Actually, we can even reuse the same register here. So we can just, we only need to jump out. We don't actually need to we don't actually need to do anything with those positions. Okay, so let's get number here, and if so if RCX is what is if R14 is smaller than RCX, so if our number is, if we are to the left of our number, then we're gonna jump out. Then we're gonna jump to skip number. And we're gonna do the same thing if we are to the right of our number. Yeah. Yeah. Good. Okay. So we have here this. Hello. Yeah, it did. I've also uploaded them to YouTube. No, finally. So yeah, you can see them there, definitely. Yeah, cool. Okay. Right, so we have this number. Actually, no need the actual number value, and we can use RCX again because we don't actually care about that one otherwise. Okay, now what? Now that's kind of tricky. So what are we gonna do here? I guess we need like the current gear state. Actually, you know what? We can do something. We can maybe keep track of the gear first before we do anything else. Yeah, I think that makes more sense. So actually what we do is, yeah, we actually reorder those. Um, yeah, let's, I'm not sure. The thing is, yeah, we should probably do that in the array immediately. We shouldn't have like an intermediate thing here, because I don't think that's actually very useful. Yeah, let's reorder those. Let's keep track of the gear first. Yeah, so let's do that one after, and keep track of this here for the next line. Okay, so yeah, we have our offset into our array for the next number, right? Yeah. So we are gonna move where? We're gonna move to so first of all we're gonna need RBX to actually like dereference our pointer, because it's pointer to pointer, right? As always. We're gonna do current gears, actually, not previous gears. And we are gonna watch current gears. Yeah, current gears is RBX, and our thing we're gonna move into is current gears plus plus the, okay, so RCX is the current gears offset, current gears plus, so it's RBX plus RCX, yeah, that one, RBX plus RCX plus field offsets, if there are any. And so what do we do? Position, number, right, okay, so we're gonna save the position first. So immediately in that thing, we're gonna move R14, and then, yeah, the other ones are gonna be 0. So we need to 0 them out though, because we might have reused this buffer, right? So plus RCX plus 8, it's gonna be 0. Actually, yeah, no, we need to do it like that. 0 out the numbers. The part numbers, actually. Yeah, okay. And something interesting we're gonna have to do, actually, is we might not... I think that, like, the way it's meant to be done is that it's always the first number divided by the second... Actually, no, it's not. Wait, how do you do this gear ratio? What is that? Like, it's not supposed to do floating point anything, right? Wait, it's the two numbers multiplied together? That's not what a ratio is. Wait, what? That's not how ratios work. Okay, cool, that makes things easier. Okay, I guess, never mind. So I was thinking we had to, like, check which one's larger, because it's always, like, we're not doing those, we might not collect those in order. Maybe? Yeah, if they're, yeah, if, no, actually we are. Maybe not. But it doesn't matter, because it's just multiplication that makes things so much easier. Okay, never mind. Okay, cool. That's good. Okay, so we kept track of this one. And now, we're gonna check the previous one. And, yeah, okay, so... oh, and we need to increment our offset, actually add gets offset 3 times 8. Because we've saved our thing in there. Are you on day 4 already? No, I haven't done part 2 of day 3 yesterday. Only part 1. Yeah, so... yeah, we're doing part 2 first. I'm actually not sure if I'm gonna be able to do day 4 today, because I don't have that much time. But we'll see. I do want to finish part 2 though, at least. And day 4 looks pretty difficult, to be honest. So yeah, we'll see. I've only skimmed it so far. but yeah. Okay, so we have kept track of our gear. If we find one previously, actually we should check if there's an immediately preceding number before this one also, because that's easier, I think. Actually, yeah, we should. Right, so if we find one here, then what? Okay, we first check if there was one already. In that case, we add a second one, and in the end, everything is fine. Yeah, in a way. If there is one already, we add a second one, and we keep track of our gear number. We keep track of the gear ratio, right? Because that one might be valid in that case, and if it is, we know what it is, so we can keep track of it already, and we might need to invalidate it later, but that's easy. Right, okay, so we're gonna oh, actually we need, what do we need? Oh no, actually yeah, we need to do this again. I actually need to find our current gear offset thingy, whatever again. And so that one is an RCX, of course. No, that should be an RDX, because we're using RCX here. Right. Okay, so if we had, that's our position. We know that one's okay, presumably. Oh, actually, no, it could have been invalidated already, so we should check this one. So if this one has been invalidated, then what? I guess it shouldn't have been. No, never mind, it shouldn't have been, because if we invalidate something, we can immediately jump out of the loop. Yeah, so that's okay. So we don't need to do that comparison, but we do need to check if the first number is 0. This one is 0. And if it's not, then we do first already set, right? And then, yeah, and otherwise, this is the first number. This is either the second number or an invalidating number. Right. Okay. Wait, first, what is that? Okay, if this one is the first number, then it's easy, right? We can just move into this one, RDX, and jump to skip number, which isn't, I guess it's not the best name maybe, but yeah. We can skip our actual name number logic thingy. And if the first one was already set, we need to compare the second one. So RCX plus 16. Oh, not with RDX, with 0. No, that one's move. Whoops. Yeah, that one's correct. Okay. And if it's not 0, then we jump to invalidate, which, yeah, that one's a bit more tricky. And otherwise, this is the second number. We just move into this field. And we don't just move into this field, we move into this field and add it to the, to the total at its gear ratio. So we do multiply RDX with our first field, and then add that one to our total sum. Okay, cool. Hello. What's the one? I'm Angie. Sorry. Yeah, it's kind of difficult in x86, but it's actually manageable. It's easier than you might think. She says after spending 4 hours on on day 1 part 2, but actually 3 hours on part 2, 4 hours on day 1 in total. But you know. Okay, yeah, how did I misspell invalidate like that? Jesus. Okay, right. So in this case we add it to our total sum, and then we jump to skip number, right? Because we need to try one afterwards. This one. 25 would be re-implementation of roller coaster tycoon. Yeah, if it keeps going like this, then yeah, probably. If you can do passing for the 3D4 is going to be a breeze. Oh, really? Well, I'm not actually passing anything. That's the fun part. I'm actually doing everything in one pass, right? I'm just going through numbers in sequence. It's getting up quickly, right? Yeah, it is. Seriously. I mean, well, kind of. I mean, day 1 part 2 was still the hardest one probably, but day 3 was much harder than day 2 already. And day 4 seems much harder than day 3, but let's see. Yeah. Although to be fair, day 3 part 1 was day 1 part 2, right? Was only this difficult because yeah, seriously, because like we had this whole look ahead buffer thing in assembly, right? God, that was so awful. Like this one we did characters look ahead. I mean, just being able to pass the number and not doing that. Oh, and passing numbers. That's easy. That's actually not difficult. Because like passing a number is actually really easy. Like it seems like you always need library functions or whatever. Yeah, but like it's really not. If you have like I don't know, 1, 2, 3, 4, 5, right? It's just like you start at 0, then you read the first digit. That's a 1. So you multiply by 10, add 1. Then you take this whole thing, take the second digit, multiply this one by 10, add that digit, and so on, right? You're just doing this, and it's not hard. Like, you can do that. It's actually, like, super easy. Like, we had much harder passing things on there. Like, day 1 was way harder passing the text there. 10 minutes. Yeah, I don't think I can type that quickly, to be honest. Yeah, okay, so if we invalidate this one, that's I think we just move like -1 into the first one. I think that's the way to do that. That's RBX plus RCX. Move -1 into there. I think I'm at like 100 words per minute maximum, maybe a bit lower. You know what? Let's do that. I'm gonna be super slow today, obviously, but yeah. Sure. Wait, let me just switch my screens. God, which window is that? OBS really doesn't like switching to browser windows. Let me just use that window. And there you go. Okay. Taking like 2 hours, I think. Ah, okay. Okay, Jesus Christ. Okay. Ugh. Great start already. $94. Yeah. Oh damn. Share the wrong screen, damn it. Okay. Okay, wait, let me switch. Which one is that? Ah, OBS. Wait, I switched my screen. Wait, did OBS just like lose my window somehow? Is that one? Oh, it's that one. Okay, yeah. Yeah, so 94. What's my end? Can I see the assembly? Yeah, sure. Wait, I'm gonna switch back. Yeah, it's alright. Okay, so right. Invalid. Okay, so we're gonna invalidate this one by setting the position to -1, and that means we can't actually come across it again. And we need to remove our gear ratio from the total sum, right? So we need to do this exact thing again. Actually, no, we need to do this exact thing again. Because RDX is still our number, right? And then we, instead of adding, we just subtract. And then we can jump out of the loop. And we have to jump out of the loop, actually. There's not much gain typing fast anyway, so solving puzzles after that. Yeah, I know. Actually, I think like typing fast is way more useful for writing than for programming. Yeah. Are you on Linux? Yes. On Arch Linux even. Okay, so invalidate. I use Arch, by the way. Sorry, said that wrong. Why do you invalidate instead of using push and pop? What do you mean push and pop? Like I'm not using the stack here. Like this is my this is an array, right? Like RBX is. So okay, so wait, I'll show you in the data thing. Okay, so we have two buffers, right, for the gears, and we keep swapping those. That's why we have like a pointer to our array, and that's why we need to do the whole move out of current gears into RBX dance. So that's our array, or our pointer to our array, I guess. And inside this one we have like three numbers. We have our position, the first gear, and the second gear, or 0 if those haven't been set yet, right? Or if we haven't found them yet. And the thing is just if we find a third number, then this one is not a valid gear, right? So that's what the problem is about. So we need to remove it from like any further processing. I guess technically we don't, because that's like the third gear again, but that's gonna be weird. Let's try not to do that. And but like we don't need to process that one again. So we just invalidate it. We just set its position to -1, so like as if it was here. And then yeah, then we're just not gonna process it again. That's all that this invalidate does. Oh, and we need to subtract the gear ratio that we've added earlier from our total sum. Like if we wait, let me construct something. If we have like this maybe, right? This number and that number, and then we come across another number, yeah, like the 6. Then that means we like once we find this one, we invalidate it, right? Because when we were at this number, we already added 772 times 5 to our total sum, and now we need to remove it again because we realize it's actually wrong. It's actually this is actually not a gear, even though it looked like a gear earlier. Yeah, and so that's what invalidate does. I mean, I should write some of those things down that I'm explaining, honestly, because that's gonna be like so much more useful. And yeah, there's anything else. So invalidate and remove its gear ratio from the total sum. That's yeah, incorrect gear ratio from the total sum. Okay. But thought you were doing an actual subtraction rather than marking this invalid. Oh, I'm doing both. The marking invalid is just so we don't process it again. And the subtraction is this part. Okay, right, so that's... Actually, I think that's the previous numbers done. Yeah, check this immediately presumed number. Oh no, check the previous line for nodes, right. Okay, so with that one, we need to keep track for the next line, and we need to keep track of the gear numbers, this gear numbers immediately after, and I'm not sure how to do that right. was doing compiler programming on Linux and tried it on Windows and was missing some functions and includes. Yeah, Windows is weird. I know like nothing about Windows. Like I use Windows, okay, for like games and stuff, but I actually know nothing about how low-level low-level Windows works. It's yeah. Like I have to like my dad does like sysadmin stuff on Windows, and I sometimes have to ask him like what registry things do and whatever. So yeah. Okay, right. Check this in immediately preceding. I still don't know how to do that one. I'm not sure which one to do next. Wait. Okay, so one thing I just noticed one thing I need to do to keep track of is that actually we're only setting one position here, but we also need to check diagonals in the number thing. So actually, let me just write a comment for that. I don't forget that. Wait, where are we? Yeah, okay. Need to remember to check diagonals for gears. Let's only save one position, right? Yeah, because numbers like the way numbers were saved previously to gears, and I'd like to do that again, is that we're actually saving this entire range, right? One before and one after. So we just need to check that this one's inside the range. We check for a number. Actually, we already used that. Yeah. But yeah, we just checked for where was it? Yeah, we just checked that it wasn't less than and wasn't greater than the position we were looking, like the start position of the number and the end position of the number. Yeah, okay. So that part is gonna be a bit more tricky when we do that with numbers. Okay, so let's do this one. So let's just do thingy here, I guess. With initial number position, we're not using that, right? What was that one about even? I don't remember what that one was about, but yeah, use Ubuntu. Yeah, that's a common one. I'm not a massive fan of Ubuntu, to be honest. But yeah, that's alright, I guess. Just proceeding. Wait, how do you spell proceeding? That's right. Yeah, switch correctly. Okay. I know how to speak English. Yeah, and like APT is really slow and packages out of date. Like GHC on Ubuntu, like the Haskell compiler, is on like, last time I checked it was on like 8.6, which is like 5 years old. Like why would you even use that? I don't know. But if you like Ubuntu, that's totally okay, of course. Not trying to be too negative. Right, the preceding number, and we might have a preceding symbol. A preceding gear, not symbol. We're not dealing with symbols. Yeah, that one's just a boolean, effectively. But yeah, we're gonna worry about that one later. Okay, so if there is an immediately preceding number, so if there is, I guess we just check if preceding number is not 0. If it's not, then I guess if it's this, then we skip preceding skip the preceding number, I guess. And we jump to that one. And otherwise, number immediately before this one. And so we need to press that one, and I guess that's actually really easy. We just move that one into our first slot, because we know it's 0. Because we know if it's been invalidated, we wouldn't even reach this one again. Yeah, right. Actually, yeah, not even just that. Yeah, we've just added it. Okay, Okay, so if it's there, then we move preceding number, which doesn't work. So actually move that one to AX first. And use AX, yeah. And then move that one in there. Current machine has Rocky Linux and the packages are crazy old. Just build and install new packages manually when needed. Artist better for the kind of stuff. Yeah, see, that's the kind of thing. Like, I mean, yeah, like have the benefit of using like Arch Linux or Ubuntu or like any other distribution is just being able to install packages easily. And that's just easier on Arch. Although like half my friends use NixOS, so I guess I should get into that sometime. But you know. Haven't really gotten into Nix yet. Okay, so we have the preceding number and we're just gonna save that one. Yeah, okay. And this one's super easy. And otherwise we're here. And we have this one for numbers immediately after. So that means we just move. Actually, we reset preceding numbers were. And reset preceding gear to 1. Let's swap those just to keep up the order here. Actually, misspelling preceding. Nix is definitely laboratory. Yeah, it is. Same about Nix. There's a learning curve, but that shouldn't be too difficult for you since you want to ask me. Yeah, I know. I have friends that are writing books about Nix, I should really be able to get into it. But yeah, I don't know. I actually have a use case. Like I have some OCaml stuff and like OPAM, the Common Package Manager, is not great. So Nix on OCaml is just a much better experience, but had some weird linker errors though, so I'm gonna need to figure that one out sometime. But, you know. Okay, so wait, right, so I think our symbols should be entirely complete. Yeah, we have checked if there's a preceding number. Actually, wait, yeah, so what are we gonna do? I'm gonna keep track of this number. We're gonna check if there's an immediate preceding number. We're gonna check the previous line for numbers, and we're gonna keep track of this gear. Yeah. Ooh, okay, great. Usually the reason for linker errors in Nix is because you're using Nix and non-Nix stuff. Maybe, yeah, I think. I don't know, honestly. Like it's linker errors because it can't find libc somehow, but I don't know. I'm gonna need to figure that one out. Yeah. But okay, we have finished symbols, and that's great because gears. I keep saying symbols. We have finished gears, and that's great because the gears are the easy part, but we've got them like really cleanly separated this time, unlike yesterday. So that's great. Actually, I think we just need numbers now. And oh, actually, on ignored, we need to reset our two preceding things. So here and preceding number. May I ask why? Why watch? Why x86 assembly? Because it's fun. Okay. Oh yeah. See, good thing I wrote that one down. Would have already forgotten about that one. Okay, so right. Now no. Nix with only defense using this shared object files as a Nix store. Yeah, I know, but I don't know. Like I'm doing exactly what was what the thingy I was using for OCaml said I was supposed to do, so I don't know. And like assembly, yeah, because it's fun, because assembly is great. And because, like, come on, would you have clicked on my stream if I weren't doing it in assembly? I'm not doing the single clicks, but, you know. Just think it was fun. Okay, so what do we do? Actually, I actually really like this like battle plan here. So let's do that one again. So we need to keep track of them. Actually, we need to keep passing the number. Oh no, that's that's actually kind of tricky. I guess actually we can do this a bit more intelligently. I think we can. Because what we can do is that we nice. Okay, so what we can do is that we do the. Actually, yeah, there's an easy way to prevent counting those twice. I think. So what we can do is that we like check the diagonal first, then check like only on the first one, and then we only check the one above, and then once we hit our last number, we check this one. But it might need look ahead, but I guess we can do something like unget C or what it's called in C, where like we have one character of look ahead. I think that's doable. And then we can like once we hit this one, check this one, and then backtrack to our main function. Actually, we don't really care because this one. I don't know. My audio is clipping. Oh, wait, I think I'm too close to my microphone. Is that better? Is that better? Maybe. So it's leaning forward a bit. Yeah. Okay. Great. Sorry. Okay. Wait. Let me actually move my mic back a bit. Yeah, that should be better, right? Hopefully, maybe. I don't know. Okay. So next number. So we need to do what? You draw lines between the numbers, you get Mickey Mouse. What? You draw lines between the numbers, you get Mickey Mouse. Okay. The numbers we need to define. Okay, back the diagonals. Or the diagonally preceding inwards. Gears. Actually, like immediately preceding. Very misspelling preceding. Yes. Check for diagonally. Diagonal. What's diagonal gears on the previous line, I guess. We don't need to check for a gear afterwards because we have like a thing there. I remember this number for the next line, and remember this number for immediate for a potential here immediately after. Right. Okay, so we can do the last one first, I think, because let's just move. Oh no, we can't. Actually, we can only do that once we're done passing our number. Actually, we can't. See, we can't just do that because we need to pass our number first, but we need to do all this while passing. Actually, do we? Do we need to do that? Oh, I think we can actually take a shortcut. We can do this way. Okay, we can. No, we can do that way more easily. Oh, that simplifies it so much. We don't actually need to check everything while passing. We can remember the first position, pass the entire number, and then check like this, whatever, right? Yeah, that's way easier. Okay, so let's do that. Okay. Yeah, let's do that. Okay, so never mind. Okay, so actually, remember the first number, the first digit position, pass the remaining number, and then for every passed index or its position, do all of those. And then, yeah. Actually, it's only... Wait, actually, no, we only need to do the other ones. Yeah, we only need to check those... yeah, actually, also we do that. And then every past position to check the previous line. I guess we can do these two in one, kind of. But, okay, so let's start here. On the first digit position. Let's just move that one to our 13 for now. I don't know if that's a good idea to move that one into a register, or if we should use like memory for that. I don't know. Let's keep this in register for now. Okay, so we are gonna pass the remaining number. That means, oh, actually we need like Cordy slash registers now. That's fine. So 13 first initial digit position, and actually we can subtract 1 from that and then just like look through those, and that makes things easier. Yeah, okay, that's cool. Actually this part is gonna be pretty straightforward, I hope. Yeah. Right, but let's keep passing. So actually let's yeah. Number is digit position. It's position, I guess. Yeah, no. And now we're gonna pass the remaining number, and that's actually easy. So we just move ix or digit into UART5, and then we're gonna pass loop, pass number loop. I think I actually have a function for passing numbers, but can we use that? No, because it doesn't increment up 14. Yeah, so we can't. We need to do that ourselves, but it's easy. Like, it's really not difficult. The main thing is we need to like, or I would like to have like one look ahead, one symbol of look ahead, so we can just jump into the main loop again. Yeah, let's do that one first. So like, look ahead, char, and ooh, what's that one gonna be? Because if it's 0, no, in the file we don't care about look ahead, right? I think so. Yeah, I think so. So like, look ahead char is gonna be 0, and so reading, where is it? Wait, where's read char? Yeah. So actually we're gonna do, before we do all of this, we're gonna compare let's one look at char. Wait, how am I gonna do that? Wait, no, yeah, no, that's easy. Okay, so we're gonna compare that one. If it's not 0, then we're gonna do we're gonna jump to use look ahead. And if there's one, so we're just gonna move that one into ix. And 0 it out. And that's that actually. Return, and then we can say reset look ahead. And that one just moves, if we can just inline that, just move ix into look ahead char, and then that's like one character of look ahead that we've reset. I guess it's not really look ahead, but you get what I mean. Okay, so we are actually passing one number, and then we move ix into look ahead char. What? Some comments. We said like ix character so that this is the first non-digit character. Okay. I really can't spell today. Okay, so how are we gonna pass our number? I guess we just read the character, If it's less than 0, we'll jump out. And if it's larger than 9, we'll possibly jump out. And otherwise, x is a digit. So we'll subtract 0 to turn it into the value, and then multiply 12 by 10 and add our digit to x and keep continue. Yeah, that's it. See, that's all it takes to read to pass a number instantly. That's actually really easy. Like a natural number without preceding zeros, without leading zeros, it's always positive. I guess natural number is always positive anyway, but you know. That's easy. If you're gonna get into passing negative numbers or passing floating points, Jesus, that's way more complicated. Yeah, but this is easy. Okay, so that's our number. So R12 contains our number now. Okay, our number, actually, R12, our passed number. Okay. Right, so we passed our number. Now what? We are gonna check for immediately preceding gears. So now we're gonna compare the preceding gear. If that one is 0, then what? Actually, we can add. We can do a function to for like this checking gear thing. Actually, yeah, we do, at least in this part. So wait, where are we? Yeah, okay, so let's do that one after, sure. Actually, no, let's do that one. Yeah. Let's do that one before. Let's do, what are we doing? Add number to gear, I guess. Let's try add number to gear, because we might invalidate it. And yeah, let's not worry about that one yet. If there's a preceding gear. Where are we? Here. No, we're not here. Where are we? Oh, that's on gear. We are here. Okay. Our preceding gear is S1. Yeah, if it's not 1, we'll skip that one. So skip preceding gear. And if it is, yeah, we'll what? We'll find the gear. Actually, no, we wait. Oh fuck. That's not it. No, oh, actually, no, that's fine. We just don't set this one to 1. We set it to its index in the current gear buffer. Yeah. Okay, that's fine. So actually, on gear, where are we setting preceding gear? Here. We're not setting that one to 1, but to, what's the index in the preceding gear number? That's RCX, right? Yeah, that's RCX. Are we mutating RCX ever? Yes, we are. Wait, that's an issue. Let's not use RCX here, I guess. Or let's not use RCX up here. Let's use R9, because that's safer, I guess, in a way. Wait, oh no, this one's moving into it again? Why? We already have that one. Oh, and sure, let's use R10 and R9 here, so we don't need to remove those everywhere. Yeah, that's fine. We don't need this now. We can do R10 and R9. Also, this one isn't reading anything, so we can use R11. And I'm not sure if R10 is quality safe. I'm not sure if we can use that one across those chords, but we can definitely use it in, as long as we're not reading anything. 10 plus R9 is 8. And that's 10 plus R9. If we can use one register for that, you know? Yeah, we can totally do that. Don't need to do this plus stands everywhere. We can just use R10 as the position of our current gear in current gears. Yeah. Or actually, no, it's the pointer to our current gear, even. Let's use R9 though, because I'm not sure about R10, and I think R9 is safe. That's, yeah. R9, and Team up team already. Okay, so wait, what did I? Wait, what's this one doing? Oh, that one should just be on now. Yeah. Okay, so we have move up preceding gear. Oh fuck, no, we can't. Because we need the index now. Actually, we don't need the index, we can use the pointer. Yeah, we can save the pointer in there. Fine. Actually, yeah, let's comment that. So preceding gear is 0 or in pointer to the preceding gear in current gears. Okay, and if it is pointer, then what? There's the preceding gear, so just will move into what's free RBX. I don't know. Yeah, sure. Or actually, let's use R9 again, just for consistency. We'll move our preceding gear into R9, and what? So that's our gear pointer into our gear, and our position 0 is our pointer. Or wait, position. Okay, so now we I guess actually we can just call try number 2 gear here. Yeah, can we? Yeah, sure, let's do that. Call try number 2 gear. And let's add a comment about takes a gear in 9. A gear pointer to the gear in 9. Okay. Yeah, that's good, I think. Okay, so if we do that, then what? Yeah, I guess let's do the actual adding logic now. Is that exactly what we did down here? I think it is. Yeah, I think it's exactly this one, right? Yeah, so we set RDX, and then... actually, wait, we also need the number itself. Let's do that. Number in RDX. And so we are here, and I think we can take all of this. Just verbatim. Yeah. Let's keep skip number. Wait, actually, yeah, actually anything that jumps to skip number should just return. What's previous number done? Oh fuck, this one needs to, if we invalidate, we need to skip the loop, so let's actually move, IX. That's not problematic because we're not using IX anymore anyway. Let's move IX1. Let's not move 1, let's do -1? Sure, let's do -1. So this one, yeah, so actually we're gonna copy out all of this. Let's say we call try add number to gear, and then compare if IX is -1, then if it's not that, we'll jump to the previous number loop, and then we can actually skip this jump. Oh, actually, no, we need to do it down here. Never mind. We can't. Okay. Actually, if it is equal to that, we jump to previous number. Done. Otherwise we go down here, add X and jump back. Yeah, okay. So try it number 2 here. Returns, or actually sets X to -1 on invalidation. Slightly messy, but better than what we had yesterday. Oh fuck, I deleted my clipboard. Wait, let me just get my clipboard history. Yeah, that's what I get for copying so much. Okay. Right. And we also need to return here. Okay, so let's just go through this just to be sure. Okay, so a 9 plus 8. If that one's 0, then we know the first one's already set. If it's not 0, we know. Wait, if it is 0, we know it's not set, so with this first number, and we can just set it and return. If it is set, we skip one and we try the second one. And if that one is valid, then we just move into it and do the degree ratio thing. And otherwise, we actually invalidate it because we thought it was valid, but it's not. And so we need to remove it from our stuff again. Yeah. Yeah. I'm not sure if we need to check that we that we don't invalidate it twice. Is that a comment here in case we get stuck? But I don't think we need to. Yeah, so let's add that one if we need it later. Or if something goes wrong and we don't know what. Actually, yeah, that one is fine. We have that one, more or less. Yeah, okay, so we try to add this one. And, by the way, do we have our number in RDX? No, we don't. We have it in R12. Okay. Can we use RDX here instead of R12? I think we can. Yeah, absolutely can. Actually, no, we can't, because I'm not sure if RDX is Cordy saved and we read stuff. So let's not do that, and let's move it afterwards. Wait, where are we? Post number done. Yeah, no, actually it's only do that in calls we can keep R12, no, so can keep RDX free if we need it. Because we might. And that one's more convenient to just have as a scratch register than R12. Yeah, okay, so we have checked the preceding gear, so I guess we need to check gears on the previous line. Is that the main one? Yeah. Wait. Actually, I have this nice list here. Okay, so which one do we have? We have this one. So that's how do I think I have a shortcut for like the check mark, but I don't remember what it is. We can look it up. Okay, can't find them. No. Okay, no idea how to type the check mark. Okay, I guess done. That's the remaining number, we have that. We are checking for immediately preceding gears, so now we need to do those two. Okay, so now we need to check for sorry, for preceding for gears on the previous line, including diagonals, and we know 14 is already one past the last digit. Oh, actually, oh wait. Just realized something. One, where's our thing where we're doing the lookup char thing? We also need to decrement by 1, so let's yeah, I want to do that there. Yeah, okay. Here. Decrement since we added the first non-digit to our look ahead thing. Ist in camel. Oh, camel. Jesus Christ. Like too much on Twitter. ASCII assembly. Yes, exactly. Yeah, I've been doing day 1, 2, 3 in assembly. And I'm still on day 3 part 2, because kind of a lot. It's actually really nice. It's much more fun than day 1 part 2, definitely. God, that one was horrible. But it's kind of a lot of bookkeeping. Because like, if you do this in one pass, you need to like remember all the numbers and gears on the previous line. And then you need to remember if there was a number or gear immediately preceding another number or gear, and things like that. And then, you know, there's so much bookkeeping involved, but I think it's fine. I feel like it's a really nice checklist per case right now. And that's really helping. So, yeah. Right, so we are here. Actually, do we? Yeah, and then those two would be easy. Yeah, remembering the number isn't difficult. Yeah, okay. Right. Okay, so we go from, where did we save that one? R13, I think, right? Yeah. R13 minus 1 to R14 inclusive. Okay, so we decrement R13 by 1. And then I guess we can use that as our loop counter, because why not? Because we're not going to need it again. And then previous gear loop. Yep. Thing is, I haven't run this like once. It's actually kind of nice right now because I'm like really in the flow and just it's all kind of coming along pretty well. But we'll see when I need to pull out GDB. So, yeah. Okay, so previous gears. So what do we do? We had R13, so I guess we're just checking if there's a gear at R13. Yeah, I guess. Also, I guess we need to loop to the second loop. Ix is free, yeah, so we can use that one. So we just, I guess maybe, per iteration, X or Ix, yeah, X, and then check previous year. Yep. Just fix my music. Okay, but there are no commands yet. I haven't like set up anything interesting here. I've streamed twice before I don't have code, so you know, there's not much here. Okay, check previous here. So we are. Okay, so we're looking through all the previous ones. Actually, we could do this way more efficiently, I think. But no, I'd rather do this safely than efficiently. Which is ironic, given that I'm writing assembly, but, you know. Yeah, like we could... So we know that the previous ones are, like, in order, right? Yeah, it's on GitHub, but I can give you a link. And the one I'm working on right now is not, obviously. But, where's it? Yeah. There we go. I did do day 1. Day 1 part 2 was hell. It was so bad. Like this. Like, just look at this code. Jesus Christ. Yeah, okay, so we are gonna check the previous gears. So I guess we'll move. Actually, we can do like the pointer thing, I think, and that's gonna make things easier. We can do previous gears. We're looking through gears, yeah. Move that one to R9. We're doing random languages. No, I'm just doing assembly for now. I might switch to either Clojure or Polaris, that's the language I wrote, later if assembly gets too hard, but we'll see. It's actually alright for now. Like, I'm probably not going to be able to do... Yeah, I'm definitely not going to be able to do day 4 today. But, yeah. think we'll kind of be able to keep up. Okay, so R9. Wait, are we still using R9? No, that one was the preceding gear, but we don't care. Yeah, right. We don't care about that one. We need we care about previous gears. Okay, so we can do like the kind of really weird C thing, which actually makes way more sense in assembly. We just like take the first pointer, and instead of adding an offset, we just and like incrementing the offset like we did earlier, we can just add to the pointer itself. Actually, no, then we don't know if we've overrun our thing. Maybe not. Actually, yeah. No, let's not do that. Yeah, okay, let's do that. Sure. So I guess we'll use R10 as our limit. Then is our Henry, I guess. And so into R10 we're gonna move what are we gonna move into S10? Previous gears. And we're gonna add previous gears offset. And R9 is just gonna previous gears, and then yeah, we can loop through that one. We can add R9 3 times 8. Yeah. And jump back, and if R9 is hit R10, we'll jump out of this loop. And actually, let me just indent that one further. This makes things easier. I don't really know how to indent assembly. Because that's kind of weird. Shake through the skill loop done. Okay. Right, so we are comparing a 9 to 10, and we're gonna jump out. Okay, and so we are at a random gear, and now R9 should be, so the value at R9 should just be the position, right? Yeah. It's not a symbol, but it's a gear. I forgot to change that. Where are we? Here, okay. Now if we compare the value at R9 to R13, yeah, to R13, and it was actually, if we, in this one we should increment R13 by 1. Oh no, we shouldn't increment it by 1, should we? Yeah, we should. Yeah, we do. We are looping through the positions. Yeah, that's correct. Okay. We're comparing R9 and R13, so if we have it this one, then we're gonna R9 is already correct, and so we only need to move into RDX, although I guess we can, no, we need to move R13 into RDX, and then yeah, call triad number 2 gear, and if that one, oh actually, fuck, we're using are we using RDX? We're not. No, we're not. Okay, that's good. Because this one might mutate IX if it invalidates that. Okay, so that's fine. Yeah, so we don't actually care if we invalidated the previous gear. We're gonna try and add not R13. No. R13 is the position. Our thing is RDX, but it's already in there. Yeah, so we just set a comment. Yeah, we just call triad number 2 gear. Okay, so we have checked the diagonals, and we have checked every past position. Okay, so we need to remember this number. Yeah, it's easy. Once we're out of this one, we do move into, let's use R10, because why not? Our previous numbers. Now add our previous number. So I guess we can use R9. Let's use R9. Yeah, sure. Previous numbers offset, and now I guess yeah, we just move into R9 our should have done that like this earlier. That's way easier. Like if we do the pointers directly instead of like offsets, you can see. Right, so previous numbers is an array of start and a number. Oh, actually, we mutated our start position. We can't do that. Okay. Yeah. So take R13, and now that we've decremented, I guess we could like we should save that one first. Yeah. Should do that because then we don't need to like remember this one across things. That's less messy. So like, let's do this here. Take R13. Yeah, I think we can do that immediately. So we're only gonna do the diagonals anyway. Yeah, we can do that. Yeah, okay, and then let's yeah, pass the remaining number and then save it immediately before checking any corners or anything. Wasn't I doing something for 13? Yeah. Yeah, check R13, we don't want to do that. Last digit and R13 earlier. We need to go from R13 to R14 inclusive. What's that move doing there? I'm not sure. Let's hope that wasn't important. Okay, sure. Right, so we have passed our number, we've set our lookout thingy, and 12th month number. Save our last number. I guess we can do both. I guess remember next line is what that one's supposed to say. I don't know where that went. Okay, so we need to remember this number for the next line. That means, clipboard history. Yeah, so we move R9. R9 contains a pointer to our previous, to like the element in previous numbers, where, in current numbers, oh. Let's hope I didn't mess that up anywhere else. Oh, I think I did. Yeah, let's look at that. Wait, video. Check that. We didn't. Okay. Right, so into R9 we're gonna move the start position, that's R13, and move into R9 plus 8, or end position, that's R14, very clean, and move into R9 plus 16, or actual number, which is R12. Wow, that's clean. And let's copy this comment I had down here. No, not that one. Did I remove it? Can't find it. Okay. Never mind. Wait, what am I doing here? Oh wait, that's what I just wrote. Yeah, okay, that's good. That's fine. It's kind of easy to get lost in assembly sometimes. Okay, so that's our number for the next line, and now we'll also move into leading number, our number R12. Okay, cool, and that should be everything, I think. I think that's it. Oh, Jesus Christ. Okay, yeah, I think that should be that. Let's do this one in a second. But also we need to do new lines. I think new lines are easy. I think we just need to reset our 14. Yeah, we need to reset our 14. And we need to swap our buffers. So we swap our number buffers. Let's move X, what's that one? Previous gears. Nochmal so fast. Gear fast, ja. Move X previous gears, AVX current gears, move gears, yes. AVX, move current gears, IX. Actually, it's kind of cute. Like, everyone knows how to swap variables in C, right? You need like one temporary variable. In assembly, you actually need two, because you need to go through a register to move between two memory locations anyway. So like, you just need two registers anyway, and then you can just swap them. It's actually a bit more elegant than assembly technically. Kind of, in a way. Yeah, okay, so let's swap them together first, and A over the length. Yeah. Buffers. Okay, so and here's offset, actually offset thing. Buffer offset. Okay. Right, so Rex is gonna be our current gear offset, and actually no, it's yeah, it is. So we're gonna move that one into previous gear offset, because we've just swapped them. And we're gonna reset our current gear offset. Okay, cool. And then we can jump. Actually, and we need to also clear preceding flags. Might need to do that somewhere else as well. So clear preceding gear and clear preceding number. Oh, I didn't do numbers. Oops. Do the exact same thing for numbers. The previous numbers. And those are current numbers. Okay. Right. Oh, that should be 0, not 9. That would be problematic. Okay, let's try and fix this. 9. Oh, it says not. Oh, so that's a byte actually, not a keyword. Oh, I think I declared that as a keyword. Yeah, here should be a byte. Oh, JNE, use lookat. And then lookat SHA-0, and that should be a byte, and that shouldn't move into IX, but an AL. And I need to clear IX first. It's from here, A9 plus 8. That's a keyword. And you're a second number on. Oh, you're also keyword. I need to do that one a bunch more times. And you are what? A combination of opcode and operands. Why? Seriously, you can't do. Oh, that needs to be animal. That's why. I don't know what mul is about in x86. I think that's only like 32-bit or something. I don't know. But like, you need to imul if you do like regular register stuff. I think it's mul like 128 bits or something. I think that's like div works like that. I don't know. Mul. I don't know. Okay, so this one is a keyword. And then you are a oh, wait. This one shouldn't be that. It should be 0, and if it's equal, skip the preceding gear. Right. And it's a keyword. Keyword. Keyword means 64 bits, by the way. In case you didn't know. The other part nodes, those are keywords. Once again. And that's also a keyword. So it's this one. And also this one. And this one. That's you. It's just keywords everywhere. Keywords all the way down. And those are keywords. These aren't actually flags. But, you know. Okay. Let a brush. Oh, where was that one supposed to jump? Into loop. Okay, let's try it. And it goes into an infinite loop. Of course it does. Actually, not that surprising, to be honest. Oh, did I even check for... yeah, I checked for end of file. Or did I check on end of file when passing numbers? No, that's... yeah, that's lookup does that. I don't know. Let's take small input, I guess, and fire up GDB. Oh, GBinit, confirm. Oh, those don't exist anymore like that. Yes. Yeah, just do that. Yeah, that's better. Oh, it's not actually waiting for anything, it's just going in infinite loop, right? Check previous gear loop done. That one's looping. That's the one. Let's try that. Restart. Now, yep. Actually, I guess let's go through the circle instruction. Wait, done jumps back to what? Something there. Like previous gear loop. Oh, and that one jumps into to previous gear loop. So yeah. Wait, when does... oh, this one doesn't exit. Oh, that's why. Okay, that explains a lot. Yes, if 13 hit a 14, and if it's we're going inclusive, so if it's greater, then we're going to jump into previous gear loop done. I wasn't actually using that one before, was I? No, I wasn't. Okay, that's good. Wait, that's the wrong one. I mean, I wasn't. Those are just suffixes. Okay, that should be better. And it exits with 0. Okay. I just got done with mine today's task. Okay, and Angstrom. Nice. Doing different language every day. Oh, nice. Yeah, somebody's actually going surprisingly well. Like it's a lot of bookkeeping. I'm doing day 3 part 2 because I haven't finished that from yesterday. But it's actually going surprisingly well. Much better than day 1 part 2. That one, Jesus Christ, that was bad. But yeah, day 3 is actually not that bad because there's a lot of bookkeeping involved in like keeping track of numbers and gears and stuff, but it's all relatively nice to write on something. Yeah. Yeah. Actually, was Angstrom that useful this time? Because like, there wasn't... like, this isn't really the kind of standard language structure you pass with parser combinators, is it? It's more like 2D... I don't know, just writing into a 2D array thingy, I guess. Yeah. I don't know. Maybe I'm biased because I'm doing assembly. Okay, so that's that loop, and now it's returning 0 for some reason. Was it returning 0 in the full input? Yes. Okay. I just wanted to do parser combinators for once. Today was simple enough. Yeah, okay, that makes sense. Yeah. Yeah. I don't know, actually, I've never used parser combinators in OCaml. Well, I've used parser combinators once in OCaml, and I wrote the library myself, and it was horrible, and like led to exponential pastimes where like parsing a file would take like 10 seconds for 100 lines because I messed something up. So maybe I'm a bit biased, but I don't know. Like, okay, so thing I'm always kind of wondering in OCaml is how do you do like mutual recursion? Like how do you do like, I don't know, say you have like an expression parser, like programming language, and you do like an expression as something, and maybe you have like curly braces, and then list of statements, and then you have a separate statement on terminal that like also mentions expressions somewhere, right? How do you do that? Because like in Haskell that's easy, that's just like mutual recursion and laziness. But like in OCaml you can't just have mutually recursive definitions that don't that aren't functions, right? You can't do like parser1 equals min what files or whatever it's called. And parser2. Like that doesn't work, does it? Oh, I've always kind of been wondering that. I guess I could just try angstrom and find out, but you know, I'm doing assembly. Okay, so where was I? At debugging. Really wondering why that doesn't fire. Let's actually construct an example. Let's do like something simple. Yeah, let's do that. 6. Oh, that works. Okay. So let's enumerate examples again, I guess. Kind of nice about day 3 is you can just kind of try a bunch of examples. Like there aren't that many cases. At least in my thingy there aren't that many cases. What about this one? Oh, that one. Yeah, that one doesn't work. Is that one preceding and then one after it? Okay, so let's see what's going on. Break, but on number, I guess? On, what's it called? On, there's no number? Oh, yeah, right, there's no number. Let's add an on number. Will make debugging a bit easier. Yeah. Rejection number. Actually, let's do on here. Okay, so previous numbers is 0, current numbers is 0, 1, 9. So that's position here. 0, 1, that's wrong. That should be 2. Oh, that's why. Okay, so this one is being counted because it's one short, because I probably forgot to increment. No, wait, I didn't forget to increment. I used 14. What's that? Right, so I'm passing numbers. 14 is our initial digits position. So that's, yeah, that's, here it's 1 in this case, because we're 1 based. And then I'm decrementing this one by 1 for the diagonals. Yes, that's correct. Then 14 is not. Oh, wait, actually, 14 is the initial digits position. Yeah, it is. Oh, actually, I need to increment 14 in here. Oh, completely forgot about that. Yeah. Wait, what? No, I need to increment 14 and then call rechar. Yeah, exactly. And I'm doing that one at least once, so it should work. No? Okay. 0 true. Okay, but now the bounds are correct, but that's not the issue, or not the only issue anyway. Okay, so there is a number there. Yes, I'm gonna break on triad number 2 gear. And that one's being called, okay. And let's look at it's at R13, I guess. That's a long array. So that's 3? Yeah. What did I do wrong? Oh, $13. No. Okay. Wait, it's not R13, it's R9. That's why. Okay, so it's 200. 1, 2. Oh yeah, 2 and it's 2 zeros. Yeah, that's correct. And what's the Fiona's? Okay, what's just the number again? It's RDX, right? Yeah. So RDX is 8. 8? Wait, 8? Oh! No, so this one isn't being added. Why not? Huh, okay, that's strange. Why's that not happening? Okay, let's rerun, I guess. And on gear, okay, let's step through. Okay, so keeping track of this one, it's fine. Whatever. Skipping preceding number, because there is none. Yeah, okay, so we are gonna check the previous line for numbers. Okay. We haven't did our offset yet. So we'll check previous numbers. Excuse me. Oh, that's why. It's not IX, it's IX. Plus, wait, it's IX. No, it is. No, it's IX. No, that's correct. Damn it. Okay, so that's correct. Also should be correct on the first one anyway. Where am I? Wait, where? Where's that? Previous number loop done. Wait, what? It jumped out? No, that's wrong. That's very wrong. What? What's happening here? Previous number's offset is 0. It should not be 0. Oh, I probably messed up previous and current somewhere, didn't I? Okay, let's do previous numbers. Where are we doing that? Checking, that's correct. We're swapping on buffers, that's also correct. Are we doing that correctly? Yes, looks correct, yeah. And that's what we're using previous numbers. No, that looks good. And are we remembering current numbers correctly? Yeah. No, that looks fine. That seems fine. I don't know what's going on. So it's I don't know, look at GDB, I guess. Like okay, let's print our counts as well. Here's numbers and numbers offsets or offsets. As a long. And the same one with our current numbers offset. Okay, so that should yeah, I know that doesn't actually do much. But yeah, okay. Error in consist file. Current numbers offsets. Did I misspell that? Yeah, it's offs. Did I write offsets? Yeah, it's offset, obviously. Okay, cool. So I guess we'll break one number. Okay, look at code. Okay, so we don't have a number yet, obviously. That's fine. Right, so digit is 9, that's fine. We want R13. R13 should be 0 now. Yeah, it is. That's the start of our thingy, and then we read one character. Find out that it's not a number. And so we remember it in our look at character thingy. And now we remember this number, which is from 13 to F14. Yeah, from 0 to 2. Yeah, that's correct. Like, including diagonals, it's from here to here. Yeah. Okay, that's correct. Then we do offset, so I guess R9 should now be 3 zeros. Yeah, 3 zeros. Okay. Display that actually. Now we're moving R14, so it's 2, yes. Wait, actually, yeah, we're moving R13 and R14 and our number. So that's good. Oh, I know what I know what's wrong. We're not incrementing the offset, actually. Oh, that's it? Yeah, okay. We're not incrementing the offset. Okay, that explains that. And now, operations as unspecified. Now it works. 70. Yeah, that's correct. Okay, let's try if that's. Okay, let's try a few more cases first. No, you know what? Let's try that on the full input. Just because why not? Get this one. Yeah. Okay. Try that, and that's a lot. We can try that, but it looks a bit high. I think our invalidation is not quite working. Which one is screen? Which one's the correct screen? Ah, it's not Twitch. This one. Yeah. Perfect. It's way too high. It's not even a 32-bit number. Not by a long shot. Okay, right. So let's try here. Right, let's try some of the obvious cases. Let's do the gear with a number on top and below. That one should be 51, right? What? Okay, so it's not. Oh god, something's been corrupted somewhere. Oh god. Jesus. How do I even. Okay. I guess having a nice test case is good in this case. Okay. I guess break let's break on number first. That one's correct, and actually let's break some on. No, it's not on symbol, it's on gear, because we only care about gears this time. Okay. So we'll just continue there. Our previous number offset is 24, that's correct. And our number is 9, add 1, 3. Okay. And so if we continue one more, our current numbers are, yeah, okay, that's one has been swapped, but that's at offset 0, so it doesn't matter. It's just garbage in there. And our symbol, didn't add symbols in GB thing. Okay. So I guess print something here, just with symbols. It's not called previous symbols, what's it called? It's called previous symbols, right. Hello. Oh, please, oh, come on. I forgot this. I switched my screen incorrectly. That's better. Okay. Right. Okay, so right, we can print previous gears, yeah, and we can actually display that. Still can copy here, yeah. That's display previous gears. And let's see, current gears. And same with the offsets. So the current gears offset and previous gears offset. Okay. Run those 4 lines. That should be displayed correctly. Yeah, okay, so previous gears are 290. Wait, is that correct? Wait, previous gears? Oh, it shouldn't be previous gears. Wait, why is it previous gears? Uh-oh. Okay, so gears are... Oh, gears are being saved into the wrong one. Yeah, this one was... I was correct, but it's not with numbers, but with gears, actually. Yeah, so that one... No, that's checking for gears, that's fine. Swapping all buffers? No, what? I'm confused. What about current gears? No, that's correct. Seems correct. Wait, where am I right now? I'm in on number. Oh, I'm an idiot. I already skipped one. Right, I'm here. That's correct. Okay, so it's 2, that's 9, and 0. Yeah. So that's seems alright. Oh, that's a lot in there. Right, so previous numbers 0, because they were not on that line. That's correct. Actually, should it be 0? That's surprising. Okay, but yeah, they are none. And current numbers are none because we're in the process of passing one. Yeah. Total sum is 0 because we haven't found one yet. Yeah, actually, yeah, I have that done there. Current numbers are 0. Yeah, because we're in the process of passing one. But why is that one there twice? I guess I copied too many. Yeah, previous gears is 290, 29 and 0, yes. That's correct. And offset is correct, so it only includes that one. Yeah, so everything so far seems fine. And now something's gonna go catastrophically wrong somewhere. And it's gonna like completely corrupt memory somewhere, but no idea where. Okay, so we're gonna try to pass this number and it's gonna fail immediately. That's what we are resetting. Where are we? Pass number down. Might not be returning somewhere, I guess, maybe. That might be the issue. Wait, where are we? Here. Okay. So we are remembering this number. Because, yeah, in current numbers. So we need to do that anyway. Yeah, that's good. The current numbers is now 24 and there's 139. Wait, 1? That seems incorrect. That's incorrect. That shouldn't be 13, it should be 02. Why is that 13? Oh, because I'm 1 past? No. No, that's not the issue. Wait, let's... This was, counting... position. Wait, why is it 3? Oh, wait, no, why is it? Wait, that one is 2. Actually, no, that is 1, 3. Wait, did it count that one as 0, 2? Uh-oh. No, it didn't. I think it didn't. That was the previous one. Never mind, I'm just, yeah, I'm just confused. No, that's correct. Yeah, that's how it should be, I think. Yeah, that looks alright. Okay, good. So, yeah, preceding number is going to be R12. That's going to be 9, that's correct. And now our we're going to reset our preceding gear. Why are we resetting our preceding gear? Oh, no, we are we're not resetting, it's a compare, not a move. Right, we're checking our preceding gear. And there was none, so we should skip that one. It's preceding gear. And now we're checking previous gears, and I guess that's where things go wrong, presumably. Although I've like assumed a lot right now, currently. Yeah, so okay, R13, R14 are not overlapping, obviously, so we aren't skipping things yet. And instead, yeah, we're looking at previous gears with our previous gear offset. Yeah, we are looking through all of those. So 10 is our boundary, and move it to a 9 or pointer into previous gears. And previous gears is that one, yeah, so that should only do one iteration. It should do exactly one iteration, rather. Okay, so we haven't hit our boundary yet, so to compare the value at R9 and R13. What's the R13? R13 is 1. Right, that's our position, yeah. Wait, our position is 1? No, it's not. Oh, our start position is 1. Yeah, right. The one we are looping through. Yeah. That one's 1. So we're looking at this position. Oh, wait, so that's 3 iterations, but 1 in the inner loop. Yeah, okay. Okay, back on track. So it's checking that one against the only symbol, which doesn't exist. So, yeah, that doesn't matter, I guess. Oh wait, if a gear checks a previous number, does it count things twice? Like if there's a 2-digit number here. Does it count that one twice? Wait, let me just write that down somewhere. Yeah, I know. Where do I write that down? I know. I'm gonna open the text file, I guess. Check damage. And something like that. Does that count in 99 twice? I don't know if it does. If it's not answered in real time. Currently studying computer science and software engineering and doing what you call advanced computer architecture. Oh, nice. Sim is a big part of it and don't understand one tiny bit. Oh, okay. Well, in advice studying it, I need to understand the operations and how things work. I don't know. Honestly, I just I just learned assembly by just writing assembly. You know, just for fun, because you know, it is fun. I don't know, you can try Advent of Code in assembly. I wouldn't recommend Day 1 Part 2. That one was horrible. Yeah, honestly, just try using it, try getting to grips with it. Like, it's kind of annoying to Google, but yeah, just Google for instructions, and Google what the instructions do, Google how to do things, and you figure it out. It's not actually that complex. Well, so like the basic concepts in assembly aren't actually that complicated. Like there are calls, there are jumps, there are moves, things like that, right? And like basic things like add, and then there's like a million super complicated instructions that I don't know. And there's like a bunch of complicated interactions, but it's actually not that many moving parts. At least like the basic subset of assembly. And also I only know x86, so might not apply to every architecture. Just, you know. Okay, so what are we doing? Okay, wait. So R9. Wait. Okay, the value at R9. Right. That's not R13 because we're checking 1. So that one should. Wait, why are we comparing and then calling immediately? Oh, because we're not actually checking that it's true. Ha! That's why. Give add number. Oh, but we are gonna count things twice. Like, this one is gonna be problematic. Ah, that's gonna be so annoying. How do we even do that? How fun did you lose a loved one and are you depressed? No, I did not lose a loved one. I'm just doing things for fun. Okay, so wait, that one's gonna like increment our total sum, yeah, and then on the next iteration it's gonna do the same thing again, right? Yeah, it totally is, and that's why our sum got so large. Or actually, negative 648. No idea what happened there. But it's, I mean, it's completely wrong. So I don't know. This is Visual Studio Code. You don't need. I'm not using Visual Studio Code for anything interesting. I'm just using the terminal, right? Like I'm just running NASM and GDB directly. Like you don't need your editor to do anything interesting. Like there aren't even any completions or anything. It's just a text editor with fancy syntax highlighting. Well, actually, not even that fancy syntax editing, to be honest. Okay, wait. Right. So I've fixed that part, but should still count things twice, right? Yeah. So that one's 81. So this one is fixed. But with this, it's gonna be 0. No, that's that's correct. Wait, that's correct. What? Why is that correct? I need Visual Studio Cheese and it doesn't work on Mac. No, you don't. You just need some assembler. Like I'm on Linux. I don't know what assemblers there are on Mac. I'm on Linux, so I'm using NASM. I know there's I think it's called MESM on Windows. I don't know exactly though. That's the Microsoft one, and I think NASM also works on Windows, but I don't usually write on anything on Windows, so no guarantees. I have no idea about Mac. Sorry. Okay, so wait, why is this one working? That's surprising. Okay, or is invalidation just completely broken? Oh, it is. The invalidation is completely broken. Why is that broken? I think NASM is on Mac as well, at least the tutorial I used for day 1.1 mentioned it. Ah, nice. Okay, that's cool. Yeah, I think NASM is just like cross-platform. Pretty well supported. Okay. Something's going horribly wrong here, and I have no idea what is. Oh, actually, wait, that one... No, that should trigger what I thought it should. So that's one number. Right now, current gears, here we're here, yeah. Current gears is 2990. So, yes, 2, this is 99, and this is, and well, there is a 0 so far. Tutorial, can I get a link? Any chance that somebody... Well, I don't have a nice tutorial, sorry. I really don't have anything to recommend. It's just, like, try things for yourself. That's all the advice I can give, honestly. There really aren't any great assembly tutorials that I know, anyway. If you have an M1, it's an ARM CPU. Ah, right, yeah. So if you have an M1, you just have a different instruction set, anyway. Right, where was I? Okay, so current gear is correct. Previous numbers is correct. 0, 3. No, it's not. Yeah, it is. Yeah, it's 0, 2, 1, 2, 3. Yeah. 0, 2, 3, 99, 0. Yes. Oh, that's so bad when I'm checking. No, wait, when I'm checking symbols. Actually, I think that might even be what I want to do. Wait, right. Let me just check that one first before I get back to debugging this. How am I checking gears again? I'm only checking once, right? I'm not checking like 3, right? Yeah, and I have used the... Oh no, yeah, so that's correct. This one shouldn't cause any issues. Yeah, that's good. The target audience is quite small. I don't think so, actually. Like, no, actually, I don't think so. Because, like, everyone learns assembly in university, right? Or actually, I mean, like, most people learn assembly in university, right? And also, like, I mean, I guess I like compilers, so I'm a bit biased, but, like, every compiler writer needs to have a pretty decent understanding of assembly, right? I don't think the target audience is that small. Like, I think you would reach more people with an assembly tutorial than with, like, an OCaml or a Haskell tutorial. Or maybe not Haskell, but OCaml. And yeah, hex 402000 is the memory address. Not sure which one you mean, but it is, probably. Oh, this one, an RSI, that's the, I don't actually know what that is about. Not sure if I said that one. Oh yeah, that's from, no, I have no idea. Oh wait, which one's the instruction pointer? It's IP, right? Yeah, no, it's not the one. Yeah, I don't know what RSI is about. It's something somewhere did that. Yeah, right. Okay, but we're not counting numbers twice. That's good. This one was wrong because we aren't looking at those three spaces. We are counting this one as like taking up this entire space and only counting once. So that's fine. What about the other? Wait, what about? Not new window. Text file. Yeah. What if we have something like if we have a start and number, that's also correct. Because we are counting this one, this one, this one, and all of this individually, and gears are always only one. Yeah, that should be fine. We can call hex 14. Is that just getting the RSI register, or I'm storing data to the address? I'm not making things up. Where am I calling? I'm not doing anything with that one. That's just what's currently in the register RSI. That's the value in there. I don't know why that's there. It might not even have been me, because I think like system calls when I read a character can modify RSI. Actually, that's probably no. I know what that is. That's the address of my input buffer. Yeah. That's the address of that one. That's why. In the second box. Yeah. I don't know what you mean. But yeah, so the thing is, RSI is the address of my input buffer, because when reading a character, I'm doing a system call, and that one takes an input buffer and RSI as a parameter. Right? So that's why that's in there, and I'm not touching RSI afterwards. That's fine. Okay, but I have no idea what's going on here. So let's actually jump ahead one number. Right, and now 891. That's good. Yeah, it's 99 times 9, right? Yeah, that's correct. 99 times 9 is awesome. Now what? Now we're reading another 9 over here. Yeah, that one's... whatever. And then what? And checking the previous gears? Or not? I've tried number. Yeah, wait. Where am I? Skip my number. Here. Right, yeah, I'm checking the previous gear. Right, the one I just fixed. Right, so that one, I'm shrinking on 13, because there's only one gear. And now this one should hit. Yeah, this one should be a hit. So I'm calling Triad number 2 gear. And it exits. Oh, I know what I'm doing. I'm not returning. Right? I'm returning. At first already said I'm jumping to invalidate or returning. Invalidate, I'm returning. Oh, never mind. I am. Okay, then that's concerning. Okay, let's break. Actually, let's reset the breakpoints. And let's break Android number here. And that should be the first one. And that should be the second one. Yeah. Yeah. That's 891, that's correct. And now the third one. Doesn't exist. What? It's not calling right now. Yeah. Why? What? What? Oh, I'm confused. Right, so, 14 is 2, that's... So we're here. That one's being added to... wait, we're here? No, we shouldn't be here. Why is that 14 2? Oh no, we are here, and we're adding that number. Right. Yeah, that's... I should remember how my own code works. Okay, so that's fine. And now, the next one, we're here. So after 14 is 4, right? Because we are one ahead. We are adding 9 to this one. Yeah, and that should be fine. Yeah, so this one is current gear is 299. And once done, it should be 299.9. Yeah, 299.9. Oh no, oh, I just skipped one ahead. Right. Okay, so we are here in Triad number 2 gear. And something here is going wrong. Horribly wrong. Why? Because this one should jump into invalidate. Yeah, so it is invalidating. And how's it doing that? Setting previous gears to -1, that's correct. And then multiplying those two. So now RDX should be... RDX is completely wrong, that's why. Ah! I'm not calculating that one correctly. Why am I not doing that? That's a fantastic question. I'm not sure. Number? Wait, what? Oh, that's the wrong one. Yeah. No, RDX is the number. So I guess RDX is wrong on input. I guess we are not setting RDX correctly, maybe? Let's rerun you and look at RDX. RDX is 99, that's correct. RDX should be 9, and it should be 9 again, but it's not. Ah, so that's wrong. Okay, so this one, when checking for those, is not adding RDX correctly. Why is that? Because RDX does not actually already contain our number, but why not? Where is our number? Not 12, right? I guess let's move it then. And that's why I prefer using auto reference. And that's 0. Yeah, that's perfect. Okay, so that's correct. I guess let's try the full file again, although yeah, I'm not super confident it's gonna work. Actually, that looks fine. That could be the answer. So, let me switch my screens. And, yeah. And let's try it. This looks a bit large, maybe. Yeah, that's the right answer. Woo! Finally. Woo, we got day 3 fully completed. And yeah, I'm not gonna be able to do day 4 today, unfortunately. But that was fun. Wow, that was actually by far my favorite today. so far. That one was really nice. Actually, I really liked that one. Because there's a lot of like bookkeeping involved, but it's not like with Day 1 Part 2 where it's just this massive like decision tree. Like this one was just a lot of thinking about edge cases and like yeah, like keeping track of things and keeping track of the right things and like getting all the conditions correct. Yeah, but I like that one. That was really fun. Okay, yeah, so I'm gonna find someone to rate. Thanks for watching the stream. There's no way you're answering those questions in Simile language. What do you mean? Okay, I'm probably gonna stream tomorrow again, so if you have some questions, I guess you can join in then. And yeah, until then, meta streaming.
Was? Sitzt du hier noch so faul rum?
Ads. Okay, yeah, so it was a fun stream. I'm gonna rate meta now, and see you hopefully tomorrow. Yeah, I'm not sure if I'm gonna have enough time, but yeah, if I have enough time, I'll see you tomorrow, and until then, bye everyone.